Imagine driving beneath the ocean. Above your head, millions of tons of seawater are pressing down with enough force to crush buildings like paper. One tiny mistake, one crack, one leak, and the tunnel could flood within minutes. For decades, engineers believed building a massive underwater highway tunnel in these conditions was nearly impossible. But China didn't just attempt it. It built one of the most advanced underwater tunnels ever constructed. A project so complex that giant machines worked beneath the seabed with millimeter precision, while engineers fought powerful ocean currents, unstable ground, and crushing water pressure. How did they actually pull it off? And what incredible technology made this engineering miracle possible? Let's dive beneath the sea and uncover one of the greatest construction projects of the modern world. Why build a tunnel under the sea? China's economy moves at incredible speed. Every day, millions of people travel between cities, and countless trucks transport goods that keep the country's industries running. But many important regions are separated by wide bays, rivers, and coastal waters. Traditional ferries were too slow. Building enormous bridges wasn't always possible because shipping lanes needed to stay open for massive cargo vessels. The solution? Go underneath the water instead of over it. An underwater tunnel would allow traffic to flow day and night without interfering with ships above. It would shorten travel times, reduce traffic congestion, and strengthen connections between major economic hubs. But there was one huge problem. Building beneath solid ground is already difficult. Building beneath the ocean is an entirely different challenge. The enemy below the water. Imagine trying to dig through a mixture of mud, sand, rock, and groundwater. Now, add millions of tons of seawater pushing down from above. This is the environment engineers had to face every single day. Unlike mountains, the seabed constantly changes. Soft soil can suddenly collapse. Water can rush into even the smallest opening. One unexpected pocket of loose ground could destroy months of work. And because workers were operating deep underground, every decision had to be almost perfect. Even tiny measurement errors of only a few centimeters could create massive alignment problems kilometers later. The tunnel had to be strong enough to survive earthquakes, powerful storms, constant groundwater pressure, and decades of heavy traffic. Failure wasn't an option. The giant machine that made it possible. Instead of using explosives, China relied on one of the largest tunnel boring machines ever built. From the outside, it looks like an enormous metal monster. Its rotating cutter head is covered with hundreds of hardened steel cutting tools. As the machine slowly spins, it grinds through rock and soil while hydraulic systems push it forward. But digging is only half the job. Behind the cutter head, another system immediately installs massive concrete tunnel segments. These curved concrete pieces fit together like giant puzzle blocks, forming a waterproof ring around the tunnel. As soon as one ring is completed, the machine pushes itself forward, and the entire process repeats. Day, build, sail, move forward, again and again, day after day, month after month. This continuous process allows engineers to excavate while simultaneously constructing the tunnel behind the machine. How they keep the ocean out. The biggest danger wasn't the digging. It was the water. Ocean water naturally wants to force its way into every tiny crack. To stop this, every concrete segment was manufactured with incredible precision. Between each segment, engineers installed powerful rubber gaskets designed to create watertight seals. High-strength bolts locked every section together, forming an extremely strong tunnel lining. Behind the walls, specialized grouting material was injected into empty spaces between the tunnel and surrounding ground. This filled gaps, stabilized the soil, and prevented water from finding a path inside. Thousands of sensors constantly monitored pressure, movement, and tiny structural changes. If anything shifted even slightly, engineers could detect it immediately. The result was a tunnel designed to remain safe for generations. The hidden technology inside. Building the tunnel was only the beginning. Operating it safely every day required another level of engineering. Powerful ventilation systems continuously replace air inside the tunnel. High-capacity drainage pumps stand ready around the clock to remove any unwanted water. Emergency exits are carefully positioned throughout the tunnel to provide safe evacuation routes if necessary. Fire detection systems, surveillance cameras, traffic monitoring equipment, communication networks, and intelligent control centers all work together every second. From a driver's seat, the journey feels simple. But behind the scenes, thousands of sensors and computers are constantly protecting every vehicle that passes through. It's an invisible safety system that most travelers never even notice. When people drive through this underwater tunnel, the journey lasts only a few minutes. But beneath those few minutes lies years of planning, millions of hours of engineering, gigantic machines, advanced technology, and the determination to overcome challenges many believed were impossible. This isn't just a tunnel. It's proof of what modern engineering can achieve when innovation, precision, and determination come together. As countries around the world continue building even more ambitious infrastructure, projects like this show that the biggest obstacles are often the ones that inspire humanity's greatest achievements. The next time you travel through a tunnel, remember, you may be passing through one of the greatest engineering miracles ever built beneath the sea.